Hey everybody, this is Unit 10. This is the review on three-dimensional solids. I encourage you to pause the video and try some of these problems on your own and then come back and check your answers. A water balloon in the shape of a sphere with a maximum diameter of 10 centimeters is filled. Okay, so there's so many clues here that it's volume. It's filled, it's asking you what's the volume. They want it to the nearest cubic. Okay, these are all hints that it's volume, centimeter, of the water inside the balloon. So if you remember, a sphere is anything like a basketball, a tennis ball, and the diameter is going to be the distance from one side of this figure to the other. Well, in our formula, which is given to us, the formula is 4 divided by 3 times pi times the radius cubed. Now, if you remember, the radius is going to be half of the diameter. So to find the radius, we're going to take 10 divided by 2, and we're going to get 5. Then we're going to plug that right into our formula. 4 over 3, when you put it into the calculator, remember to keep that in parentheses. We're going to multiply that by pi. We're going to multiply that by 5, and we're going to raise it to the third power. So if you have your calculators, we can do that together. Parentheses, 4 divided by 3, close the parenthesis. We're going to multiply that by pi is in blue, which is right up over here above this up key. So second pi, close the parenthesis. Then we're going to put in multiplied by 5, and we're going to raise that to the third power. And then we're going to arrow out, and we're going to get our answer of 523.598. And what did they want us to round to? Oh, to the nearest cubic centimeter. That's the whole number. So since the next number after that decimal point is 5, then it's going to end up being 524, and we're in centimeters, and it's actually going to be cubed, cubic centimeters. Great job. Let's go to the next one. The next one says, what is the volume of a cube? Well, a cube is actually a square, a three-dimensional square. So the base of a cube is a square, which means all the sides are congruent. It says one of the edges is 12. So the length is 12, the width is 12, and the height is 12. So it says to find the volume in let's see, what is the volume of the cube with edge length of 12 centimeters. Okay, so they gave you the formula. Now be very careful here. Capital B and lowercase b mean two different things. This capital B means the area of the base formula, and we just talked about the base in the shape of a square. So you can either do length times width, or you can do side squared, whatever you feel more comfortable with. So the volume is actually length times capital B part times the height. So the volume is going to be 12 times 12 times 12, which comes out to be 1,728, and we're in centimeters cubed. The next one, it says find the volume of the right rectangular pyramid as shown. Well, again, this is a pyramid. Here's the formula. It's 1/3 times capital B. Remember, that's the area of the base formula. And in this case, the base of the pyramid is rectangular. So the formula for a rectangle of area is going to be length times width. So what we're really using is 1/3, capital B is going to be length times width, the area of the two-dimensional rectangle, times the height, the distance from the vertex down to the center of our pyramid. So we're going to do 1/3 times the length of 10 times the width of 12 times the height of 16. So as you can see, where I plugged it into the calculator, our volume comes out to be 640, and it's going to be, there's no real set of units, so we could just write units cubed, or you could just leave it as 640. Fantastic job. I'll meet you on the next one. Okay, my printer cut this one off, so I had to just kind of draw this one in. It says a packing carton in the shape of a triangular, that's going to be the base, prism, as shown in the diagram below. What is the volume in cubic inches of this carton? Well, here's the area of a triangle formula. Why do we need that? Because capital B means area of the base formula, and you know the area of the base of the triangle is 1/2 times the base times the height. And remember that the bases of any prism are the congruent parallel sides. That's why this is a triangular prism. So let's write that down. So write this down somewhere. The base of a prism, the bases of a prism are the congruent and parallel sides. So we're going to need to know that later on. So let's do the first thing. We're going to find the area of the two-dimensional triangle. Now the base has a length of 6 inches and the height is shown here as a length of 3 inches. So it's going to be 1/2. The length of the base is 6. The length of the height is 3. And when you plug that into the calculator, 6 times 3 is 18. We don't even need a calculator. Half of 18 is 9. So that's going to help us over here to find the volume. Capital B is the area of the base formula. All right, so the area of the two-dimensional triangle, 9, times the height. Now the height is the distance between the congruent and parallel bases. So the height in this case is going to be 10 inches, the distance between the congruent parallel bases. So look at that. We don't even need a calculator again. 9 times 10 is 90, and the unit of measure here is inches, and it's inches cubed. If you don't feel comfortable with the unit of measure, you're not going to get it wrong if you leave off the inches cubed, but you would get it wrong if you did 90 cubed, because that's not the right answer. So the inches, the unit is cubed, okay? Just like up here, the unit is cubed. You guys are doing a great job. I'll meet you right on the next page. Number 5, find the volume rounded to the nearest tenth. So it says put everything into the calculator and round to the tenth of the right circular cone in the diagram below. Well, look at here, pi r squared, isn't that the area of a circle? So it's 1/3 times the area of the circle times the height. So we're going to, nice and simple, 1/3, I like to put my fractions in parentheses, times pi, times the radius is the distance from the center of the circle to any point on the circle, in this case is 14, times the height, which is the distance from the vertex perpendicular to the base, which happens to be 29. When you plug that all into your calculator, you're going to end up with 425.16. It says round to the nearest tenth, so your final answer, 425 point, that 1 will round up to 2 since the next number is 5 or more. And if you want, you can always put units cubed. Excellent job. The next one, what is the volume? In terms of pi, so do not put pi in the calculator, of the cylinder represented in the diagram below. Well, this is the cylinder formula. It's pi r squared, the area of a circle, times the height. So let's plug in what we know. The volume is pi times, what does the 12 represent? Ooh, that's the distance from one side of the circle to the other. This is the diameter. We're looking for the radius. So we know that half of the diameter is going to be equal to the radius. So we actually need to use 6 in this formula. So 6 squared times the height, which is 27. Let's plug that into the calculator. So remember, the direction said in terms of pi. So in your calculator, don't put pi in. I just put in 6 squared times 27. So my volume is 972 times the value of pi. And then you're done. If you want, you can also add on your unit of measure, which is centimeters cubed. Excellent job. Number 7, the Great Pyramid of Giza was constructed as a regular pyramid with a square base. All right, so that's how we're going to know what formula to use. It was built with a height of 146.5 meters and a base length edge of 230. So remember, because it's a square, the length and the width are going to be the same. And the height is the perpendicular distance, which is 146.5 meters. And we're also in meters. Okay, what is the volume to the nearest cubic meter? So here's the formula. It's volume equals 1/3. Up there's that capital B again. It means area of the base formula. And we said the area of a square, you could either do length times width or side squared. So we're going to do 1/3 times the length, which we said was 230, times 230, times the height, 146.5. So when I put that all into the calculator, I got 2,583,283.3. It says round to the nearest cubic meter, which means to the nearest whole number. So since the next number is less than 5, 2,583,283 meters cubed is your final answer for this question. And again, if you think I'm going a little bit too fast, just pause the video at any time and slow it down a little bit so you can go at your own pace. Number 8, a circular cylinder. Remember, the cylinder is going to be named by its bases. It's circular, so the bases are going to be circles. They're congruent and parallel. So if you want to draw yourself a picture, draw yourself congruent parallel circles and then connect them. So here's your cylinder. The diameter, so the distance from one side of the circle to the other, is 26. I have a feeling we might have to find the radius. So let's do that right away. Let's find the radius. 26 divided by 2. is going to be 13 centimeters. Excellent job. And the height, the distance from one circle to the other, is going to be 12 centimeters. Using the volume of a cylinder formula, which is given here, volume equals pi r squared times h, which is the height. What is the volume to the nearest tenth of a cubic centimeter? So once again, pause the video, put in your numbers, and come back and check your answer. So you should have put in pi times 13 squared, which is the radius, times 12, which is the height, and you should have gotten 6,371.14. So it says round to the nearest tenth. Since the number after the tenth place is a 4, we're going to leave that 1 as it is, and the unit of measure is centimeters cubed. In the accompanying diagram for number 9 is a rectangular container with dimensions of 18 by 15 by 22. Is to be filled with water using a cylindrical cup, a cylinder, whose radius is 4 and whose height is 7. That got cut off on my paper, but it is in our picture, 7 inches. What is the maximum number of full cups of water that can be placed into the container? Full cups of water without overflowing the container. So the first thing we're going to do is find the volume of these two figures. Pause the video, try it out, and then come back. All right, so I did the math in the calculator here. The volume of the rectangular prism is capital B. That's the length and width, the area of the two-dimensional rectangle times the height. You should have gotten 5,940. The volume of the cylinder is pi times 4 squared, the radius squared times the height of 7. I didn't put pi in the calculator. I'll do that at the very end. So to find how many cups that we can put in, we're going to take the volume of the rectangle and divide it by the volume of the cylinder. So as you can see, when I put this into the calculator, I took 5,940, divided it by 112 pi, and I got 16.8. So how many full cups of water can we put in? You guessed it, we can only put in 16 full cups. So remember, in this case, we're not rounding, right? We can put in 16 full cups and 0.8 of a cup, but it just says full cups. So you can put in 16 full cups of water. All right, 16 full cups of water can be placed into the container without overflowing. If we put in another full cup, 17, it's going to overflow. So we have to stop at 16 full cups. And the last question, number 10. A snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere, half of a sphere of shaved ice as shown in the diagram. The inside diameter of both cone and hemisphere is 4.6 centimeters. So the first thing we know is that the diameter is 4.6. Now we know a lot of times we're going to end up needing to find the radius. So let's do that right away. As soon as we see diameter, let's find the radius, which is 2.3. The height of the cone is 12.8. So determine the volume in cubic centimeters of the entire snow cone to the nearest hundredth. Woo! Okay, let's not forget to round to the correct decimal point. So what are we going to do? We're going to find the volume of the cone, and we're going to add that to the volume of half of a sphere. So be careful here. This is the volume of a sphere formula, but we're going to need only hemisphere. Hemi means half. Okay? So we're going to take this formula and we're going to divide it by 2. Alrighty, so you should have found the volume of the cone to be 1/3 times pi times the radius, which was 2.3, we talked about that, squared, which is half of the 4.6, times the height of 12.8, which comes out to be 70.90784,059. And remember, the volume of a sphere is 4/3 pi times the radius cubed, but remember, the cone on top is it's a hemisphere, so we're doing half of that. So the volume is 4/3 times pi times 2.3 to the 3rd power cubed, then divided by 2, which comes out to be 25.48250521. So now to find the volume of the entire cone, we're going to add those two numbers together, and I did that right here on the calculator. So we find the area of the entire cone to be, let me see if I can write this down. I'll just rewrite it here. Volume is 96.390. And remember, we're rounding to the nearest hundredth, which is the second decimal place. So since the next number after that number is 0, less than 5, our final answer is 96.39, and it's going to be centimeters cubed. You guys are doing a fantastic job. Keep up the great work. Don't forget to copy down all your notes, take a picture or scan it, and then upload all of that into the submit button through Canvas. Keep up the great work. If you have any questions, please feel free to reach out. Be well, everyone. Bye.